This is Unit 41 about the periodicity of element. So we will try to focus on several change, for example, melting point, boiling point, or conductivity. So let's start. Now, first of all, here shows a periodic table again. Now, as you know, the periodic table, the atoms are arranged by relative atomic number. Now, don't mix up with atomic mass. Atomic number, have a quick revision, is actually equals to the proton number. Right. So here we have 4 categories, and in the DSE syllabus, we only focus 2. That is, first, the main group element. That means the element you can tell me what group is it. Most generally is from group 1, group 2, 3 to 0 or group 8. It depends on how to interpret. All these elements in red are actually we call main group element. Next one is something new for you. It's called transition element. That is the element in green. So we will talk more about this in Unit 44 or 42. So stay tuned. And the xanthanite and austenite will be skipped here. And sometimes they are known as rare earth metal. So maybe you heard this name from TV news or newspaper. So here are the 3 points we try to interpret here. Is first one is the charge. No, not the charge, is change from metal to semi-metal to non-metal. Now, metal rock is also known as semi-metal. They behave like non-metal, but there is some special properties, so we will talk about this later. The second one is how it changed the conductivity across the period, and finally, there is a maximum melting point. The melting point, it depends on the structure. So with the structure change from metallic to giant covalent, and then simple molecular, so you can expect the melting point will change. Now, first of all, please help me to fill in this table. So now you can pause the video and do it by yourself first. And here is, so you can expect, for example, for the metal, it belongs to group 1 and group 2. Here shows group 1, group 2, group 1, group 2, and group 3 maybe. They actually get strong metallic bond between cation and delocalized electron or mobile electron. They got metallic structure, no problem. And of course, they got good conductivity. So these are the properties of metal, which mostly allocate in period 1, no, not period, group 1 to group 3. Well, the next one is giant covalent structure. Of course, they got strong covalent bond, and the conductivity is poor because they don't have mobile ion or mobile electron. And sure, you got an exceptional case is graphite. Well, otherwise, everything simply you can classify them as insulator. Finally, is those typical non-metal. They got strong covalent bond between atoms, but weak van der Waals force between molecules, and got simple molecular structure. Yes, they are always poor conductor or insulator. And here shows, for the noble gas, they got monoatomic molecule because they don't even form covalent bond. And I'm sure all these elements or all these properties you have learned in grade 9 or in the early grade 10. So here is just an revision for you. Next one, we try to explain the conductivity. Yes, for the metal, they are conductor of electricity. The reason behind is the presence of delocalized electron. And you can expect for this delocalized electron, more will be better. Because if you get more delocalized electron per atom, okay, per atom, then you get a better conductivity. This is reasonable. And next one is, so with this idea, we can expect those group 2 elements will get better conductivity than group 1 because they get more mobile or delocalized electron per atom. The next one, with the same idea, group 3 will be the best electrical conductivity, right? So here is the trend. Because there is what? There is an increasing number of mobile electrons. Let's highlight it in the outermost shell and hence increase the conductivity. Well, this is expected, right? And something is more about those students who hasn't studied physics. And that is, when temperature increase, actually the conductivity will decrease because higher resistance. That's why, for example, those electronic devices, they cannot stand for too high temperature because if got higher temperature, then the conductivity will get some problem in their circuits, okay? The next one is, what about semi-metal? Semi-metal, as I mentioned, they are also known as metal rod. And first of all, the electron is held with strong covalent bond. Typical examples are boron and silicon. And there is something strange here is, well, at high temperature, those bounded electrons can get more kinetic energy, and now they become delocalized and become mobile electron. And that's why you can expect their conductivity will increase. That means for this semi-metal, the temperature higher, the conductivity will also higher. That looks strange, right? But now we understand this is because some electron or some bounded electron bounded by the covalent bond is now become mobile. Well, the final one is non-metal. So of course, they are insulator because there is no mobile electron. I think this is easy for you, right? Next one, please have a look on this checkpoint. So maybe you can pause the video first and after do it, you play again. Now, in this question, so you will ask about the change in electrical conductivity for the element in period 3, that is from sodium to argon at room temperature. So, first of all, I'm sure some of them are not the answer, right? A will not be the answer because we know that for the metal only, the conductivity should increase, right? And then D is also wrong because it is not reasonable for those non-metal get conductivity or even higher than those metal, right? And with the same idea, B is also wrong because it doesn't make sense for the silicon get the highest conductivity. So of course, our possible answer is C. And with this idea, so first of all, non-metal insulator, okay. Aluminium got the highest conductivity, reasonable. But what about sodium and magnesium? Actually, they got slightly increased. Yes, because they got more mobile electron. in the outermost shell, and it is quite difficult for you to understand why there is such small change from group 1 to group 2, but large change from group 2 to group 3. So we will discuss it later. And of course, don't worry, this is out of the syllabus for explanation. Next one, we will talk about what about melting point. Now, with the melting point, so again, we try to fill in metal first, okay? All right, let's back. And here shows I have filled in the blanks. Now, first of all, I'm sure everyone knows that they got giant metallic structure, right? Yes, and from group 1 to group 3, as I mentioned, we can expect that the delocalization become more and more delocalized electron evolve. So we can expect the strength of metallic bond increase. Not only about the conductivity, but you can expect the metal become stronger and stronger. So the melting point, of course, will increase. So if you don't believe it, so try to remember the following case. Sodium is such a soft metal that can be cut by the knife. Right. But aluminium is strong enough to, for example, making knife, making fork. So the metallic bond, or we can say the melting point, boiling point increase across the period, at least for metal. So for those students who love math or love physics, so here I give you an illustration. For every single electron, a mobile one, okay, in the metal, so here they shows the attraction between the metal cation and the mobile electron. So if you study physics, so you can remember the force between them is actually the charge become them and the charge and over some constant, okay? So you can expect for aluminium ion, I got 3+. So of course, my attraction will be stronger than those sodium ion, which only got 1+, right? So more charged cation here. And of course, then the attraction will be stronger and melting point will be higher. Well, this is only part 1. So if you are careful enough, so actually the size of iron also decrease. That means the size of aluminium ion is actually smaller than that of sodium ion, because for the aluminium ion, I got 13 protons, but for sodium, I only got 11 protons in the nucleus. So the outermost shell electron will experience stronger nuclear attraction in aluminium ion. Okay? So that's why aluminium ion will be smaller in size. But sodium ion will get larger one. Alright, so of course this is not in scale, okay? But the next one is about the silicon, which is a giant covalent structure. So again, please write it down by yourself first. Get a pause and write it first. And here shows giant covalent structure. The atoms are bounded by network of strong covalent bond, and hence we need many energy to break the networks between atoms. Now, so please pay attention. Here you see, I use the word between the atoms. Finally, is the non-metal one. First of all, let me write it down. The structure is simple molecular structure, but something is strange. Is the melting point actually in this order? This looks strange, right? Because if you study the group, it is neither in ascending or descending order. Sulfur got the highest one, argon got the lowest one. So what's going on? And here will give you the idea is because their molecular size is different. For phosphorus, the molecule exists as P4. Sulfur we got as A, that means A atom to build a molecule. Chlorine is, we have familiar with that. And argon is monoatomic. So we can expect the size of molecule, or more precise to say is the number of electron, is actually increased with this idea. Yes, sulfur got the largest molecule and argon got the smallest one, and of course the strength of van der Waals force will also follow this trend, right? Because in unit 23 we learned that the strength of van der Waals force depends on the size of molecule or the number of electron in the molecule, right? So here is, that's it. So don't worry too much. And here shows you how the P4 molecule or the S6 molecule looks like. Next, please help me to fill in this checkpoint on page 8 for question 25 in 2017. So you are asked the variation in melting point. So of course, some of them will not be the answer. For example, D, A is surely incorrect because there's no point for the sodium get the highest melting point or aluminium get the highest one. And with the same idea, C is not correct because silicon should be stronger than that of aluminium in melting point. So finally, the answer is boy because the signature here. So you can mark it down. This is the signature in the melting point because of the different molecular size. Next one is the trend about metals in purity free. So first, incorrect. So melting point or metal, yes, this is actually correct. Aluminium gets stronger. And the next one is electronegativity is also stronger. Don't forget, electronegativity is the ability of attracting the outermost electron to the nucleus. So aluminium got more proton. Of course, the electronegativity is stronger. And what about reactivity? Yes, sodium is got higher reactivity. And finally, what about the base strength? Now, the basic strength, sodium got stronger because once sodium oxide dissolved in water, they will combine with water to form sodium hydroxide. So it got stronger base strength. So, oops, sorry, this is not correct because aluminium oxide, no, sodium oxide is stronger, which is a strong base, you know. And aluminium oxide is a weak base. So you can expect aluminium oxide is hardly dissociate when dissolved in water, right? So it's a weak base. Next one is, which of the following statement about the periodic table is correct? First of all, the melting point increased down the group? No. With group 1 element, that means everyone got only one outermost shell electron. So the melting point should be decreased down the group because increased atomic size will weaken the strength of metallic bond, right? The second one is the boiling point increased down the group. Now, this one is correct because increased size will increase the van der Waals force. So B looks good. C, the elements arranged in order of relative atomic mass. Yes, so some student will be trapped here because he or she just see relative, but in fact is atomic mass, not atomic number. Okay, finally is conductivity increased from left to right. Of course not. If this is correct, that is noble gas got the higher conductivity, right? It doesn't make sense. So the answer is boy. Next one, melting point of silicon is higher than that of aluminium. Correct. The number of electrons in silicon atom is greater than that of aluminium. Well, this one is correct. But this is not the reason, because the melting point here actually depends on the structure, but not depends on the number of electrons. Okay, if you still don't understand, let me use another story. Okay, if the melting point, okay, if the second statement is correct, does it mean more electron will become higher melting point? Well, if this is true, then again, noble gas got the highest number of electrons in the period. So the noble gas should be highest in melting point in the period, right? So again, it doesn't make sense. So the answer is B. Both statements are correct, but they are not related. Okay? Next one, the melting point of non-metal in period 3 decreased from sulfur to argon. Well, that means sulfur got the highest melting point, then chlorine, then argon. It looks good because we know that they got different size in molecule, right? The next one is the relative atomic mass. Okay, again, they always place the same trick. They try to mix up between atomic mass and atomic number. So be careful, okay? The atomic mass increased from sulfur to argon. Hey, is the atomic mass increased from sulfur? Sulfur is 32.1, chlorine is 35.5, and argon is almost 39 something. Okay, okay, I cannot remember. Okay, this makes sense. This makes sense, but again, is it because the melting point depends on the relative atomic mass? No, right? No one say the atom is heavier, then the melting point will be greater. So again, this should be B. So hope you can follow, okay? Well, next one is this is very extremely important. I think this is the core of this chapter. Is the behavior of their oxide in water. After they dissolve, what's going on? Now, here shows. First of all, please remember all these 3 notes. The first one is non-metal oxide are acidic. Okay, something is more or neutral. A good example will be CO versus CO2. CO2 is sure acidic, right? But CO is neutral. So they are either acidic or neutral. The second one is metal oxide are basic. Okay, of course, we got exceptional case is aluminium oxide, so I will tell you later. Finally, what's wrong with aluminium oxide? Here is something new for you, so please pay attention. Aluminium oxide is something called amphoteric. That means it can act as an acid or a base. It depends on what compound is going to react. Okay, so first of all, please write it down. Aluminium oxide is actually insoluble. So if you forget it, let me remind you once more. Aluminium oxide is used to anodizing to get better corrosion resistance. So of course, this is not water soluble. Okay. Now, the next one is a very important statement. So please be alert. It appears in past paper and many students get wrong.